Today's video is going to cover lesson 2.7, evaluating functions. This is page number 14. Evaluating functions is actually what you did yesterday when you completed the table for a function using the rule. So the goal today is to be able to evaluate a function for an output when provided an input and a function rule. So that's what evaluate a function means. It's trying to figure out what the output is for a given input and a function rule. So what does that look like? A couple key terms today. And actually there's just one. It's function rule. So this is the kind of definition of what a function rule is. It expresses the dependent variable. So our dependent variable is normally y, in terms of the independent variable. So this isn't anything that you don't already know or haven't been exposed to. It's just a little change of pace. So this function rule is usually an equation. Usually you see function rules expressed as an equation. And so going over when it says expresses the dependent variable in terms of. So what does that mean to take the dependent variable and write it in terms of the independent variable? So if we look at what that means, our independent variable in algebra is always x. And how do you express x in terms of the independent variable? Well, if x is the independent variable, then x is just x. But what about y? Now that's the change. So the dependent variable that we're familiar with is y. So how do we express y in terms of x? We just say that y is a function. So a function of x. That's what y is. It's just a function of x. So a function of x is oftentimes how you express the dependent variable in terms of the independent variable. Or you can say f of x. So you'll see this throughout the remainder of the year, where we have f of x equals, let's say, x plus 2. So here's our function rule. Here's x, our input, and here's y. Here's x, our input. It's listed twice. This is just our input. This is our output. So it's f of x is our output, and that might be an important thing to write down, that f of x represents our output. So this entire thing is our output, and then our input is what we put into the function for x. And you'll see that as we go through these examples today. Example number 1. Evaluate using the following function rule to find f of 7. So if you're looking at this f of 7, we're trying to figure out what the output is when our input is 7. So we know that our input is 7. We can represent this as an ordered pair. We learned about the definition of an ordered pair the other day. So if our input is 7, we're trying to figure out what that corresponding or what output it matches. So in order to do so, all we really have to do is we just have to plug in what we know x is, or what our input is, for x, and then simplify to figure out what the output is, or what f of 7 is. So that looks like this. We've got f of 7 equals 3. We're putting in 7 for x here, and it's being multiplied. I can put this in parentheses, or I can just write a dot for multiplication. I'm going to put it in parentheses, minus 14. Now we're just doing order of operations to simplify. Multiplication comes before subtraction. 3 times 7 is 21, minus 14. 21 minus 14 is 7. So we can say that f of 7 equals 7, where 7 is our input, and coincidentally 7 happens to be our output, and our ordered pair is 7, 7. Example number 2. Evaluate using the function rule to find f of negative 28. So we have our function rule. We're going to use negative 28 as our input, and we're going to figure out what the corresponding output is. So we've got negative 28, comma, and whatever we get after we simplify will be our output. So we've got f of, our input is negative 28, equals, and now we're inputting in the negative 28 for our x, which is right there, divided by negative 14 minus 3. So order of operations, we're going to divide before we subtract. Negative divided by negative is positive. 28 divided by 14 is 2. 2 minus 3 is what's left. 2 minus 3 simplifies to a negative 1. So we can say that f of negative 28 equals negative 1, where negative 28 is our input and our output is negative 1. We can go ahead and write it as a ordered pair. So these two things right here are actually the same exact thing expressed in different ways. This is an ordered pair. This is expressed as a function rule. Example number 3. Evaluate using the function rule to find f of negative 2. So we're going to put in, I thought I was going to go the distance with this one, but I didn't. I failed you guys, sorry. F of negative 2 equals, and now we're putting in our input every time we see an x. So in the previous two examples there was only one x that we put our input into. Here there's 2, so we're going to put it into both of these x's. So we've got negative 2 squared minus 3 times negative 2. And now I'm using order of operations, PEMDAS, for those who have forgotten what the order of operations are. So now we've got some exponents to simplify. So we've got exponents come before multiplication or subtraction. So we're going to go ahead and use our exponents. And in fact, I'm going to make sure that I use a calculator so that I don't make a mistake. So we've got negative 2 squared, and the square feature is right there, minus 3 times negative 2. Boom. And this is actually exactly what I have here. So when I hit enter, my value is 10. So I know that f of negative 2 equals 10. Minus those multiplied minus 3 times negative 2. That would be 6. Bring down the 4. 4 plus 10. Yep. So that is correct. So f of negative 2 equals 10. And our ordered pair here is negative 2, where our input, and 10 was our output. Alright, this will be the last example today. Example number 4. Evaluate using the function rule to find f of negative 12. So we're going to set this up. 2 in a row, man. We're going to set this up where we put in negative 12 for x. So we've got negative 4 times negative 12 plus 2 times negative 12 squared. I'm going to go ahead and use a calculator for this example to ensure that I get it correct. So I've got clear negative 4 times negative 12, and the parentheses here for your input are important. If you do not use your parentheses, then the answer you get will be different from the answer you should get. And the squared feature is this caret x caret 2 squared, and what do we get? We get 336. So we can say that f of negative 12 equals 336. 6. Our ordered pair here is -12, comma, 336. So those are the examples today. This is how you evaluate a function when you're given the input and you're having to find what the output is. Good luck on the problem set. Feel free to message me or any of your classmates in Schoology if you are having trouble as you are working through the problem set. Good luck.